Well, my mother was visiting her folks in New York when she decided that it was time. And I was the first child, and I guess she was a little surprised. So I was born in New York, even though we didn't live there.
That's great. Now, are
And
you recording yet?
and
Yes, we're recording.
and as soon as we were able, we were back in New Jersey, where she and my father lived. My father was a chemist, and even at a young age, he was always taking me into the plant where he worked, showing me things. And I kind of had a mechanical bend or bent, and as with most youngsters, if it's something your folks are interested in, why, you're somewhat interested. I grew up in New Jersey. I ended up in high school in Hillside, New Jersey, which was a small town. It was primarily dairy farms. And we used to kid in high school that in our civics class that there really was no industry in the community. It was interesting because after the war I went back there and I looked and you couldn't really find anything but industry. The town had been overrun. I After graduating high school, I attended Cornell University. And after the war started, I tried to get in the service. At that time, I was rejected for a number of reasons, but they primarily said stay in school, and not only that, he had bad eyes. And of course, as the war progressed, they got a little bit more desperate for people, and I ended up enlisting in February of 1943. I thought I was going to Texas to develop training aids for the Air Force. However, it turned out the Army at that time, I remember it really wasn't the Air Force, it was the Army Air Force. And it turned out the Army had better ideas and more need for infantry, especially since things really weren't going very well in the North Africa. After completing basic training in the infantry, I ended up on cadre training new infantry soldiers at Camp Wheeler, Georgia. The company commander told me one day that they had a requirement for having a certain number of their company show up to take what they called an OCT test, and right away thought it had something to do with officer training. He assured me it wasn't. Most people in the infantry do not want to become an officer. The officers have a very high casualty rate in the infantry. He insisted that anybody that had college training really ought to go take the test and see if the Army had a better place for them than the infantry. It seemed like a long way to get from what I thought I was originally going to do to that. After taking the test, a few of us that were from that company ended up getting new orders and being shipped out. We went to North Carolina State in Raleigh, North Carolina State University, at which point they told us we were going to continue studies and that they had good places for technically trained people in the military. Well, this didn't sound too bad. I enjoyed it at North Carolina State. It's a good university, and the courses were quite good. They were really follow-on courses to the ones I'd been taking, which were primarily in engineering at the time. And then one day they very kindly told us, just about when we were getting used to Raleigh being a pretty nice place, and that we were essentially going to college again, they told us one morning, "You're out of here," and they shipped us to Columbus, Ohio, to Ohio State University. And then they finally told us that we were in what they called the Army Specialized Training Program, ASTP. We continued there, and for some of us, we were essentially taking graduate courses. I specialized then in 2 physics courses and some applied mechanics courses, which are really mathematical courses. And after a period of time, they told us we were done with that, although a few of the people had decided this isn't what they thought they were going to do in the Army and applied to return to their original units. One of my closest friends at the time, who had been in the infantry with me, he had come from Pennsylvania. He ended up going on over to North Africa from there. When they went through a graduation ceremony for us, now the question was, what were we going to do? They still had made no suggestion about this. The next thing I knew, we were shipped to Oak Ridge, although we didn't know that's what it was at the time. And they were building the plant in Oak Ridge. And there we were, back at what I called doing hydraulic engineering. They put you on a shovel and you're trying to drain the swamp. After about a week or so of this, and some really very strange engineering operations that they were doing, they damn near lost a bulldozer into that. They didn't realize how deep the mud was. Another morning, they read off some names of the people there and said, "Grab your gear, you're leaving." Still no question of where you're going or what you're going to do. And we ended up on a train car which seemed to be attached to various trains heading west. We had no idea where we were going. One of the fellows who was in charge was a fellow by the name of Gifford Young, who was a chemical engineer. And I think Giff had his PhD at the time, and he didn't know. He said he had orders and places where we could open them, but all we were supposed to do was stay on the train. Periodically, the car would be decoupled from the train and left somewhere on a siding with there was no officer in charge of anything and no instructions, just stay on the train. Eventually, it ended up on what we now know as the Atchison, Topeka, and Santa Fe. And after we had passed through certain parts of Colorado, which included coming down the classic line now that's still for that railroad, Giff said, talked to the conductor, and he said, "I'm supposed to get off at the next stop and make a phone call." During the wartime, most of the towns had all of their signs removed. It was a wartime protection that supposedly if there were any enemy troops that showed up, they would be a little discombobulated by not knowing, with no road signs, you wouldn't know where you were going. I'm not sure it served to confuse anybody except, of course, other people who hadn't been there like ourselves. So we had no idea where we were, although someone said it was New Mexico. It turned out that Gifford got off at Las Vegas, made a phone call, and he said, "Get your gear together." I think we had been on that railroad car for 3.5 days by that time, and it hadn't been serviced in any way, and it really wasn't a very pleasant habitat. So we get our things together, and the train stopped at what we now know was Lamey. At that time, we had no idea. It looked like there was nothing there. It stopped, but there was a 6x6 vehicle, and we unloaded and boarded it, and we still didn't know where we were. Headed off the highway and ended up coming into Santa Fe, but we didn't know it was Santa Fe. And every time the truck slowed up, we'd ask people, "Where are we?" And they looked at us very strangely, and nobody answered. The vehicle stopped at 109 East Palace, and Gifford got off, and they still didn't let us off the truck. And then we took off again and headed for Los Alamos. We had no idea that that's where we were going or what it was. We headed down the old road that runs from Pojoaque on towards the Rio, and it runs down through El Rancho and the Pueblo. And that road, of course, those roads weren't paved. It was very, very dusty. It was the middle of the winter, but there was just a little bit of snow. The dust was so bad. I still had my gas mask from the infantry, and I put it on to protect me from the dust. I'm sure we were quite a sight going down the road with a gas mask. One of the other fellows had his also. We ended up here in Los Alamos. It was late afternoon. They asked us if we had any cameras, which they said they would keep for us, and so we weren't to have them. And they brought us down to what was a single barracks building. It was double-deck bunks so close together that you had to turn sideways to move between them. And on the end of each bunk, people had their barracks bags with their belongings. There was no place to put anything. They said, "Find a vacant bunk," and that was it. And the other fellows that were there took us to the mess hall that evening, and we were ensconced in this situation. The following morning, they brought us up to a fenced area, which turned out to be the old tech area. And here in the middle of the winter, they sat us down along the fence and said we would be called one by one. That was our introduction to Los Alamos. They didn't call it Los Alamos. Nobody told us what it was. All of the people there that we had talked to that were in our barracks had technical backgrounds. Some of them with a good bit of university training, some technicians that were machinists or similar. We had seen other GIs when we drove in. Turns out some of those were from the Provisional Engineer Detachment, which was doing road work and maintenance and so on in the community. And we had seen some, we had also seen some women from the Women's Army Corps in uniform at the mess hall that evening before. Sitting out in the fence, it turned out that after they began calling names and some of the fellows were called in. Of course, as in the Army, everything was alphabetical. And the fellows came back and said, "They're interviewing us for jobs." And we said, "What kind of jobs?" Well, they asked us about our background, what we liked to do, what we did. And there are people in there that are interviewing us for jobs. And, as more and more of the fellows return, the W's are pretty far down the alphabet. I became a little concerned that all the good jobs might disappear. And I heard some of the fellows talking about some of the people that were interviewing had pretty heavy accents. And they weren't sure what accents. And some of them seemed a little strange in the questions they asked. They finally got to me, and I went in, and the person who was interviewing me had a pretty heavy Austrian accent. And he asked me about what I liked to do. He asked me if I liked music. I told him I played the piano and the trombone, and he seemed very interested in that. And I thought, this is a very strange job interview. And he asked me what kind of pieces I liked to play on the piano. And I said, well, I hadn't been playing much since I'd been in the Army. And I told him some of the things I liked. And then he talked about interests I had in technical things. And I was kind of intrigued with him, and I wasn't sure who he was. And then finally he said, okay, he said, you're going to work with me. And you be back here tomorrow, and there'll be instructions for you when you show up at the gate. And that was it. I was done with my interview. And I wasn't sure what I was getting into or what I would be doing. The gentleman that interviewed me was Otto Frisch. Of course, I wouldn't really have known his name if he had told it to me as any connection with anything in particular. The next morning I showed up, and they called him from the front office at the administration building there, and then he took me on into what was known as U building, which had laboratories in it, and then he had a large laboratory with hardly anything in it, and nobody else in the laboratory. And he said, this is our lab. And I said, oh, good. What do we do? And he said, well, we need to get some equipment, and I'll talk to you about it, and I have some things I want you to do. And so I said, well, I'm a good soldier. This is very, very strange. After a few days, he had me working on a piece of equipment that obviously had been used before and needed extensive repair. And I thought, from a basic design point of view, without knowing what it was really for, it was rather poorly engineered. And I could understand why it had so many patches and so on in there, because it looked like they had kept on modifying the thing. And he had some ideas about some more modifications, and he said, can you do this? And I said, oh, sure, I can do that. And I still couldn't figure out what it was. It looked sort of awful, but it had vacuum pumps with it and things, and I understood that basic technology. I got talking to some of the people next door in the laboratory. Turned out to be very interesting folks, and I asked them who this fellow was. I knew his name was Otto Frisch. And a fellow by the name of Dave Nicodemus that was in there said, you probably have access to the technical library. Why don't you go over and find out who Otto Frisch is? That seemed pretty good, so I headed over there, and there was a young lady there who was in charge of some of the technical reports, who was one of the WACs, and she helped me. And we looked up who's who in physics, and I found Otto's name, and I looked at what he was known for. and got very, very much impressed. Came back to the laboratory and was sitting there at my bench, and I was looking at Otto, and he was sitting at the desk. We had a desk, and I had a bunch of equipment on the bench. And when I had first come in there, Otto had said, this organization has what they call groups. And that's their description for little work centers. And we're in a physics group. And our group number is P0. And there are certain authorities that go to the leaders of the group. He said, since we're only a group of 2, I'm the group leader and you're the alternate group leader. And you have signature authority to get almost anything you want from the supply area. And that was how I got the pumps and other things to set up. So I now had a title, and I still had no idea what we were doing or anything else, and I wasn't even sure what I was working on. But having looked up Otto in the tech library, I was sitting at the thing and looking at him, and he looked up all of a sudden. He said, "What are you looking at?" And I said, "I'm looking at you. Why are you looking at me?" "Well, I know who you are." He said, "I told you who I was." And I said, "Yeah, but I think I know what we're doing. And I think I know what this piece of junk is here that I'm working on." And he said, "Well, if you think you know what we're doing, you'd better get back to work." And that was my introduction to the field of weapons. It turned out that I was working on a large fission chamber, which had been modified, that Otto told me later he had originally worked on in Denmark and then had shipped to England with him and then had it shipped over here. And he'd had all kinds of people working on it, but it had never really quite worked right. And he said, "You have a challenge," which I felt I was up to. And knowing a little more about what we were doing, I kind of thought I could fix it by making some major modifications. And I had authority to get work done over the machine shops and everything else, so I modified the monstrosity, and within a week I had it working. And Otto was mighty impressed and started suggesting other things that we would work on. Now, the reason why I'd like to dwell on this for a moment is, although I only worked for Otto for about 4 months, 4 or 5 months, this man had so many ideas, and regardless of the problem, he could think of a way of approaching it. He wasn't really quite that skilled with his hands, although he was a great pianist and gave many concerts up here in Los Alamos. And he wanted me to be his hands, and he wanted somebody to bounce ideas off of. And we became very, very close friends. In fact, I even taught him how to drive. He had never driven a car, and many people have told me since that it was a great mistake because he was a terrible driver. I don't want to dwell on the projects we worked on, except for maybe one, and we'll touch on the idea of the long hours that people were putting in those days on things. We were working really 6 days a week, and more if necessary, and there were no prescribed hours except what was required, which meant as soon as you'd gotten something to eat in the morning, you could head right up to work in the lab. And outside of probably getting back for dinner in the evening And quite often you came back after dinner and continued work in the lab. Otto had a way of thinking of things that he wanted to do, and they would come at very strange times. I hadn't been here very long when I decided to send home my folks for them to ship me my trombone because there was a little band playing here that played Saturday nights, and they needed help. And one of my friends in the service played the trumpet. And as soon as we were able to acquire our instruments, they were shipped in. And things weren't that easy to ship in to Los Alamos, but we got them. We joined this band, and we played for dances Saturday nights. And Otto used to like to come to the dances. And we were drinking quite a bit of beer in the evening on Saturday nights when we played for the dances. And almost every Saturday night, Otto would come up to me in one of the breaks and said, "We'd better go back to the lab after the dance. I've got an idea." Well, this meant going back to the lab at 1 o'clock in the morning after playing a dance. And he'd been there dancing with any lady that would dance with him, but he was single at the time. But this meant, when you think about it, that we had a long week, and then Saturday night really wasn't off. And I remember one project he had, and he said to me, "If you're clever, we'll figure out a way of doing this as a camera. And the camera will be our whole laboratory. And so we would need to work at night when everything is dark. And then we don't have to make special boxes and handholds to do things with this crazy camera. It'll be our lab." Well, this is a different way of looking at things. And we did a very interesting experiment that I constructed for that thing, which at the time I didn't understand until after we completed the experiment and we were looking at the films. And what we were looking at was the instabilities on the inside surface of an imploded ring. Now, how do you do this? Well, Otto's mind was one of those things that just took a hold. He said, if the pressures are high enough, the metals will act like liquids. So he said we would essentially implode a mercury ring and look at the instabilities of the inside surface when it had this large force imploding it from the outside. And we did this by essentially evacuating the interior very, very suddenly. And my chore, of course, was to build a piece of equipment that would do this. And it had been prompted by our going out and looking at some cylindrical implosion experiments that were being done at one of the explosive sites. And he felt the whole technique was so crude, and of course it could only take sort of a snapshot, and each time you wanted to look at more, you would have to do a whole experiment, hope that it was identical, and then just retime it. And he said, we could do this in the laboratory with this idea. Well, the thing that was known as, in years later, as a Taylor instabilities, from the Rayleigh-Taylor instabilities of the inner surfaces of materials moving this way, shocked materials, has been a very important thing in the whole business of implosion weapons systems and a concern of people. And here Otto had come up with this idea, if we could implement it. And it only took us about 3 weeks to put together this whole experiment. and do it late at night in the laboratory. And this was a mind that could grab at anything, whether it was mathematical or physical descriptions. Well, when we decided to start this new group with Al Graves and Darrell Froman, it was going to be a group to measure the hydrodynamic phenomena that occurs when you accelerate metals with explosives. And this was, Al told me I would become the explosives expert, and they shipped me to Anchor Ranch, to the casting room there, which was the only explosive fabrication facility we had at the lab at the time. They were building a site which was going to be a large facility for doing this, but our small casting room had steam kettles and all the equipment for doing pouring of explosives. I didn't know anything about it. There were some people there who were very, very knowledgeable, and I was indoctrinated in safety procedures, the materials we were working with, and how we would approach all this. And then after making a number of castings, and we even did a few experiments on the burning velocities and explosives, and doing small detonations at one small site there called Q site. Eventually it ended up that I was to write all the safety procedures and the operations for our new site where we would test methods to do these hydrodynamic studies. This site was called Beta Site, and it was out on South Mesa, kind of across from the old tech area. And when we started doing our experiments there, and the more we were able to measure, the bigger tests we were trying to do. We were actually doing them with some fairly sizable charges, and we were getting very good results in these tests at Beta Site. At that time, the whole program seemed to be speeded up even more. People were trying to get a good handle on what they were going to do for an implosion system. This wasn't really discussed, but to most of us that were working on the things, you could tell what we were trying to do. We actually set up to run the site 24 hours a day. We put essentially 2 teams on. That meant 2 12-hour shifts. And to keep the experiments going, we broke up into pairs who were in charge of the experiments and shared classified notebooks where you wrote down everything you were doing and where you were, so your corresponding person on the next shift could continue with your experiment as soon as you changed over, because you really weren't going to sit around and do a bunch of talking each time. Al Graves was my partner on those, and we shared a notebook. And the progress of the experiments and the technique was extremely rapid until a number of people were extremely interested in our results. And as we moved up into larger and larger scale tests, the people in charge at that time, George Kistiakowski and Seth Nedemeyer, were extremely interested in any result we got. So as soon as we developed a film from one of our tests and plotted up the results on graph paper, which we were doing right at the site, then one of us would rush them on up to the tech area so they would see what we were looking at, and they could analyze it or suggest modifications to the experiments. This is a very interesting period to think about, that you could be operating 24 hours a day have direct feedback to the senior people to review the technology and modify the experiments almost instantly. And that's the way we were working. As a result, by early 1945, in the middle of the winter, we were testing essentially prototypes of the first implosion system that was going to be used at Trinity. And when we thought we had done all we could, it was almost like, gosh, we're done, we're stopped. I remember it was in March of 1945 that we didn't see really what we could do to help with anything further at the time, and we began to talk about other experiments we could do, and a lot was going to depend on the people who are going to supply other components to the system. The explosive components, it looked like we had done a good enough measurement job to feel pretty confident that they would do what was required. I became intrigued with the idea of trying to get to the test. And I talked to Darrell Froman about it, and I said, well, I just can't believe that I'm not going to be down at the site for the test. And he said, well, I'm not going to get to go. We don't have anything that we have to do down there. There is nothing we can contribute. And it still bothered me that I couldn't go. And of course, I was still a GI. And then I got an idea, and I said to Darrell, if I can finagle a way for me to get down there, do you object? And I said, I might even ask you if you would assist me in my endeavor. He said, what are you trying to do? And I said, well, I won't tell you until I promote it. Well, I went down to some people I knew and asked if they had folks that were doing mapping for the area of what was there and what would happen under various wind conditions and so on. And they said, well, people had done some cursory things. What do you know about mapping? Oh, I said, having been in the infantry, I could do all of these things, which was probably a slight exaggeration, but I at least knew how to approach it. And then somebody said, well, yeah, if you can bring a team down there to do that, why, but they said we don't have any vehicles to spare. So I went back to Darrell. I said, I think I've got a way of going down. Would you like to be a mapping expert with me? He said, no. He said, I can't believe you're so entranced with the idea. And I said, well, I'm going to take one of the other fellows out of the group and see if he wants to go. He was also a GI. And I said, can I take one of our trucks, which was a large weapons carrier? Anybody who knows what the vintage World War II Dodge weapons carriers are would not think of it as a good vehicle to be driving on the highway. Anyhow, Darrell said, take what you need. So I reported back to this officer and told him, yes, I had a vehicle and an assistant, and we would be pleased to go down there and do this. And he said there was a convoy going, and we should meet the convoy at a particular place in Albuquerque. So we did, and that's how I got to Trinity. We did mapping of any dirt road that led away from Trinity site for about 20 miles in all directions, and I drew them all up by hand using a compass, graph paper, and the odometer on that weapons carrier to mark out where those roads went and what was there. Cattle, sheep herders, or any buildings or anything else. And then we were there for Trinity. So I got to be there about 10 miles away for the Trinity Test. As soon as it was over, I got permission to leave, and there wasn't a convoy leaving, but Bob Ludwig, who is with me, said, well, we can make it to Albuquerque with the fuel we get here on this thing, and we knew a place we could get it refueled. Had a little base up there, and we did, and so we got back to Los Alamos, and I went to Darrell, told him, well, we got to see it. He said, oh, we were watching up on the side of the mountain, and we saw the flash, too. So that was my story about getting to Trinity. The last thing I wanted to tell you about was the fact that over the years, Otto Frisch and I stayed in touch. And when he went back to England, we stayed in touch. Then he married and had children. And every time he came over to this country on lecture tours and so on, he'd make a point of coming through, and he always stayed with us in Los Alamos here. Every time he came out this way, he would call from somewhere and say, "Way, I'm at the University of Chicago or something. I'm coming in Los Alamos. Can you meet me?" And we'd come stay with you for a week. And so that was a nice history. Got to know his family after he had gotten married after the war when he was back in England. These were great times. There were lots of work, and it seems like yesterday. It ended up as a very interesting future for me. I stayed doing some of that work after the war in studies of materials and hydrodynamics. Made a short stint back to Ohio State to do some more studies and some graduate work and a little teaching, and then came back here to Los Alamos in 1948 in the physics division. I worked on building the first new accelerator built post-war. And then at the time of when President Truman wanted us to work on the thermonuclear project, one of my good friends, who I'd known ever since the early days here in Los Alamos, was Marshall Holloway, who was in charge of the thermonuclear program for Los Alamos, and Marshall asked me to come to work for him. I left the physics division and accelerator work and went to work with Marshall on the thermonuclear project, which got me back in the weapons system. And I remained in that in various capacities, moving up to managerial jobs after being a project manager for Marshall, and then on in, and eventually was a division leader for what was called WX Division, which was one of the weapons engineering and physics divisions when I retired.
That's wonderful. One of the things that you talked about on the phone was the reason that the project worked so well, and you touched on it a little bit, but I wondered if you just to make a couple of comments to this effect. The speed with which things were done was really a reflection of the management and leadership and how Oppenheimer ran the project.
You know, I touched on this a little bit when I talked about the implementation of a group that could respond and get the information up to the senior folks that were going to be making the decisions. And although Oppenheimer was very laid back about many things, he really selected people that were going to be in charge, and they were not going to have group discussions on what to do all the time. There was reporting, and if people didn't like what they heard or had real questions about it, they could question. But it wasn't going to be committees deciding everything. And this meant that people like George Kisiakowski and Seth Nudemeyer could make some really good decisions and as to where to go. They didn't have to turn to a whole group at the time. I'd never seen any management of this sort, except you could say maybe the military makes some decisions this way, but I wasn't enough up in the military system to recognize that. The time, Otto had seen to it that I could attend some of the colloquia, and I could hear some of the discussions that went on when Oppenheimer would do these. He didn't really dominate these meetings. He was not sort of the chairman. He was an implementer, and other people would talk about where they were and why they thought this is what they were going to do. And there were questions, there were people questioning. An interesting aspect about this was about the time they were pretty sure they could make an implosion system work, it would be obvious to anybody who knew much about the physics of the device that the simple-minded thing that we used for our modeling, and mind you, you had no computers, so the modeling was very tedious. That simple-minded beast had many deficiencies, and you didn't have to be very bright, but somewhat knowledgeable, to think of many ways you could do it a little better. And it was very interesting to see that Oppenheimer kept people on track and said, we're not trying to build the best thing that will do this job. We're trying to do something that is going to be ready here and now. And it may not be really safe, as we all know it really wasn't a very safe device. And it really wasn't very terribly efficient. And we all could think of better ways to make it more efficient. And we weren't really thinking of safety quite that much because the idea was you wouldn't arm it until you absolutely had to. So we weren't really talking about weapon systems that would go out as you might talk today. And this whole position that you maintain that says these are the objectives for this particular project, that was very, very important. And Oppenheimer knew that, and his key people knew that. And it was amazing that as soon as they fired Trinity, now everybody was saying, now we know, can we work on the things that we all know are much better? In fact, many people were already working on them. The same thing held true under Bradbury when we were tasked with the thermonuclear program. And, many of the arguments and discussions with Edward had to do with the fact that he always wanted to do, well, if this is right, then we ought to be able to do so-and-so. Well, that's fine and dandy, but you never get the project. It's always ongoing. And that's fine. And science does work that way, but you need those milestones that tell you that you didn't blow it, that it really is working the way you wanted. And the whole idea of Trinity, that was very, very frightening from very, very many points of view, because the modeling techniques that anybody could do were so crude that the ranges in estimates of what the device would do were huge. And these were by very talented people, these estimates. Now, today we think we're pretty smart, but maintaining the idea that the simplest, most sure-to-work system was the one you were going to use, that required a very, very strong management and an appreciation for where the strengths of his senior people were. And to me, those were the two of the aspects that were so critical about both Oppenheimer and Bradbury and their projects, and made them work. Now, a lot has happened. If you think about the difference in modern A bombs and modern H bombs.
Let's hold for just a second.
I'm sure you've been asked that question a thousand
Yeah,
times.
whenever you're ready, but it'll be very short.
Yeah, real short would be great.
With regard to the use of the A bomb, there are many people, and in hindsight, will look at the results and say, did we really have to do that? If you talk to anybody who had been close to what it takes to really fight a war on the ground, and even the attrition from nominal bombing with the huge numbers of bombers going over, the A-bomb was just an extension of this, but it showed a technology that was more than just impressive. There have been many arguments about whether you should have had a demonstration and say to Japan, see, this is how could you really demonstrate this to show anybody in wartime? It was a very idealistic thing to me, and something that although in principle you'd like to see, from a realistic point of view, I saw no way that such a thing could happen. And I don't wish to dwell on the idea that I was in the infantry. But believe me, from what I saw in infantry training and from what I knew from other friends and so on, the idea of her fighting a war that would involve troops at that level was so horrible to me that I had absolutely no reservations about the use of it. Now, atomic weapons in general, or thermonuclear weapons, there I can differ with a lot of people where we go. I get very frustrated when people talk about tactical nuclear weapons. Even today, when I hear this, I shudder because of the magnitude of these systems. I feel that anybody that says this doesn't understand what they're dealing with. There can be no such thing as tactical use. It's either the giant use of these, the threat of what they can do, but you can't imagine just shooting at cities in a tactical nature. In a trip I made in 1959 to Europe for the laboratory to look at what our troops were doing about atomic weapons and what their policies were and so on, I was horrified because they were describing tactical use of weapons. They were talking about using hundreds of these in small scenarios in Europe. This is ridiculous to me and has continued to be so. And so the use of nuclear weapons to me is strategic, if at all, if it's a threat. But when people talk about this, I personally feel there is no such thing as real tactical use of small weapons. It can't be. That's not nuclear.
That's terrific. That's a good answer. You're just a fount. I can't resist it. Maybe we should see if
Yeah, you
the
probably.
other person is
Okay,
here.
everybody hold for just a second. Give me 30 seconds of silence, please. This is room tone.
Okay, well, I'd like to ask a question, or see if you can talk about stripping away the inevitability of history. When you're a student and you read, well, the Manhattan Project, and of course we deemed everybody as a participant in the Manhattan Project. Did it seem inevitable that it was going to succeed? How confident were you and others that the project would work? I'd like to see if you can talk about, the uncertainty of it all, from the perspective of being there at the time.
Well, the the chance I had to get to know some of the other things going on was rather interesting. This good friend of mine who played in the band with me, I was talking about on Saturday nights. Incidentally, we ended up playing in a little band, a different one that played all over northern New Mexico. And we used to show up at Saturday nights at places all over northern New Mexico. But Don was working at the Anchor Ranch laboratories, not at the casting room. And that was the area where they were developing the little boy, the gun weapon. And I didn't understand at first what was going on there, although I'd visit Don there. I'd come up sometimes at lunchtime from the casting room. And then when I began to understand, I said, golly, what I know of the physics is pretty limited, but this thing is almost sure to work. The real question is going to be if its assembly is fast enough to where it'll give a reasonable yield. And of course, that's part of what they were studying as to how quick the assembly was. And these calculations are pretty limited, but my overall feeling was, gosh, they've got something there if they can deliver it. The only problems that you could see with weapons of that type is there are many things that can make them go off at much less than their design yield. And this has to do with excess neutrons early in the system. And so when we started looking, and I knew we were working on an implosion system, to me it was so intriguing because this thing looked like we could really make it work if there weren't some errors. And so every time you saw something coming out in the design that looked like it would smooth it out a little more or make it a little more conservative, which was part of what the leaders were doing. We were not designing. We were measuring and testing to give them information for design. When you began to see this, pretty soon you said, hey, they are doing this in such a conservative manner. It's going to work. I was so sure Trinity was going to go big. That was one of the reasons I was so eager to be down there. I just absolutely convinced this thing can't fail but to go. Now, how big? It was so, a thing like this is so much larger than anything you test with explosives directly that it's almost beyond comprehension. We had fired off tests of, at the end of South Mesa there, of like 3,000 pounds of explosives in trying to do some of these studies. That is a huge bang. And if you're in a little bunker not very far away because you have all this instrumentation, this is horrifying. Plus, for a lot of the tests we were doing, we used a periscope to sweep the area and make sure something untoward hadn't come up or that some cow hadn't wandered onto the scene. Twice I had to postpone tests because some cow had strayed and was within sight of the firing pit. Well, this meant you get a chance through one of those old periscopes that we had built into those bunkers to actually see some pretty huge explosions. They're impressive. And if you go further up the road, which a lot of our people did because we didn't have room for all of us maybe in the bunker, you were most impressed with large explosions. It's a different world compared to an atomic blast or a thermonuclear. I thought when I'd seen Trinity, I didn't have to see any more of them. And I didn't for many years. And then I was there for Mike and some of the later ones that we did because of my role in those. And again, it's completely overwhelming. So the whole business, if you're present and you have a scale, and it is not the scale you see in a movie, you can't describe it that way. And that's part of the reason why I say people don't understand when they talk about using nuclear weapons the way some of them do. And it was obvious to me, I mentioned in 1959, when I came back and I wrote a paper on this, and I said, these people shouldn't have these atomic weapons because they don't know what they're doing with them. This is incredible. This country can't believe they're going to use them that way. So, the enormity of what we have is something, I don't know how you impress on people. Now, we don't do atmospheric testing anymore, and all of our most late tests were underground, and even looking at subsidence and all the rest of it, they have no feel. So what do we have? We have movies of old atmospheric tests. They're impressive, but obviously they never impressed the military to the point that they wouldn't have come up with the scenarios that I saw in '59 and said, these are incredible. You can't be serious. Now, there are plenty of people who don't agree with me, but that's my feeling. I worked very hard during the Cold War about strategic weapons. And in the course of my career in the weapons business, we worked on many small weapons. The only ones that I thought made any sense at all in the way of using small weapons was the Navy, because they had no other way to do some of their kill scenarios for submarines that might launch ballistic missiles, etc.